as an associate professor in the Department of Electronic Engineering at Rajasthan University, Kota since January 2010. His research area includes signal and image processing, communication systems, wireless communication networks, etc. It's a great pleasure to have you as speaker for the first session. Welcome you, sir.
Thank you very much, Dr. Payal. Okay, so my expert talk is on 5G communication and role of AI in 5G. And firstly, I thank Dr. Garima and Dr. Payal for inviting me this uh, expert lecture. And before starting this lecture, I should give you some brief regarding the 5G communications technology. I know this course is running from last 3 days, so I will take a fast review of the technology aspects related to 5G. The reason behind revising these things will be to know the aspect why we need the utility of AI in 5G technology. So as we are aware, the 5G technology supports the virtual private network, and it is the internet protocol enabled devices with AI capabilities. And this supports the cognitive radio technology that we may call as smart radio also, which allows the different radio technologies to share the same spectrum efficiently by adaptively finding unused spectrum and adapting the transmission scheme. This dynamic radio resource management relies on software defined radio. And this is basically the statement which is the crux behind the need of artificial intelligence, machine learning, and other uh, software related techniques to efficiently utilize the bandwidth. So this is what you are or you might be aware with. So challenges with the existing 4G technology that we are using extensively these days are spectrum crisis and high energy consumption. We have limited spectrum, and as we are seeing in today's scenario, that not only voice and data is being transmitted through 4G technology, but we are seeing lots of video transmission by use of this existing 4G network. So the naturally the requirement of bandwidth increases, then correspondingly the spectrum crisis increases. So this is a big challenge associated with the 4G technology. And of course, we are aware as the spectrum crisis generates, the low end users suffers mostly. They feel the crisis, and that is very much prevalent in today's scenario also. Another issue is related with the latent issues related to smart network. Latency is the time taken to perform certain decision. So that plays a vital role when the vehicle or any other thing is movement is in transition from one cell to another cell. And another aspect is associated with very high data rate of transmission, which is very much difficult to achieve. So we can see by our existing scenario that 3G technology was operator centric. Thereafter, we shifted to the 4G technology that was with the aim of service centric, providing better service with better data rate. But 5G is going to be entirely a different perspective, and that perspective is user centric. The user will be able to directly connected with the World Wide Web with the distinguished IP addresses, and that provides a better service adaptability. So we will give a fast review of the things associated with the existing technology, and of course it is very much possible that you have also gone through some of these things, or we may say many of these things during past 3 days of lecture, but this will be required for us to enter into the need of AI in 5G technology. So we see as over here The motive behind the different generations of mobile technology is increasing the spectral efficiency. That is data rate, that is bits per second, that could be transmitted over a unit frequency, unit hertz. So the motive is very much clear how efficiently we can utilize the available spectral bandwidth. And of course, the reason is that initially we were transmitting only simple data or voice, but later on the challenges associated with image transmission or video transmission or over and above the real-time video transmission put a greater challenge on the aspects of 4G technology, 3G or 4G technology. That is why we are still feeling the requirement to enhance the spectral efficiency. And of course, 5G is working with this. One of the motive behind advancement of technology is increasing the spectral efficiency. So this is what we are aware with, that no substantial change took place when we shifted from 3G to 4G. UMTS, the 3G technology, and LT is associated with 4G technology. We are very much aware with this particular working. The key behind this is that no substantial architectural innovations done during development of 2G to 3G. Of course, we have increased the spectral efficiency, data rate, but as far as the overall operation is concerned, with respect to a certain device which is connected to a local cell, that philosophy remained unchanged, whether it was a 3G or a 4G technology. But instead of this, in the 5G technology, the requirement is of diverse type. We have enhanced mobile broadband requirement. Ultra reliable, low latency communication is one requirement, and massive machine type communication is also one of the requirement. And we can see that this way the remote operation is possible. With regard to smart grids, factory automation is possible, smart office or smart home is possible, and similarly smart logistics or smart sensors can be used to operate them independently by the by any of the user associated with the 5G technology. The things are shown in these two diagrams. Also we can see that existing technology will certainly going to exist, whether it is WLAN or 3G or GPRS or LTE. But now the terminal is having an IP address, and we are in a position to control different devices by using different servers. And this diagram again shows the intelligent 5G network related services that are possible. That comes IoT related services, device to device communication, direct device to device communication. That is also very critical. That didn't existed in either 3G, 4G. And similarly, operating different types of intelligent services, operating smart grid, and by the use of this, all is possible by use of client computing, and by which we are in a position to do the computing operations with the help of a remote server, and we are in a position to handle many of the things by using a simple handheld device. So this is the type of thing that is need to be required as far as the 5G technology is concerned: cloud management, network management, and by which various technologies are integrated together. Now we see that why latency is an issue, because in automation or intelligent transportation or smart grid, we can see the type of latency is in the range of few milliseconds only. So it means that gives a very vital, that is going to play a very vital role in the use of 5G technology. Then only we can use the future IoT application if our latency period is slow. See, if latency period is more, uh, then we are not in a position to do some of the utilities that we are supposed to do. So 5G is associated with the different bands. You can see there are three bands. One is less than 1 gigahertz, another one is the mid band 1 to 6 gigahertz range, and the third one is the high band, that is going up to 24 gigahertz. So as we go on to the higher frequency, we see the cell size has to be reduced. The reason behind this is that the range of transmission is very much limited as we go on to the higher frequency, because line of sight distance reduces drastically. So cell size is reduced, or you can say in other way around also, that number of antenna required in a particular area has to be increased to a greater extent if we go to the this particular band, that one is the third band. So these are relatively lesser stricter in that context. But if we go to the IoT application, machine learning or AI related applications, then of course we have to explore this particular band which works on very high frequency range. So this is the past technology that works on OFDM. So we may skip it. And 5G works on the modification of OFDM by using certain different subcarrier spacing. In the less than 3 gigahertz range, it is being used the 15 kilohertz of subcarrier spacing. If it is above 3 kilohertz, then subcarrier is of 30 kilohertz, or we can say the spacing of subcarrier increases 60 kilohertz, or to very higher frequencies, that is millimeter wave frequencies in the range of 20 gigahertz. We see that the subcarrier spacing increases to up to 120 kilohertz. Basically, this requires how many channels could be integrated in a certain subcarrier. So this is the thing that we have seen in our last slide, and this is associated with the requirement of subframe, where some overhead is there associated with these slots, and accordingly we have to manage the things. Of course, this is related to the requirement of certain standard related to that particular frequency band. So this is the layered architecture diagram. It shows that end-to-end communication requires all of the layers, but in between layers basically deals with the medium access control sublayers and physical sublayer. And 5G reliable communication is the upper part of the physical layer, medium access sublayer, and that has to be taken care of in the 5G technology. So first thing is the MIMO concept in 5G. MIMO is basically multiple input, multiple output, and which requires multiple antennas, and the reason behind is that we can handle data at a very high frequency, better spectral efficiency, better reliability is achievable in this particular type of concept, because we have used the multipath propagation. So fading type of phenomena is nullified to a very good extent. So this is the diagram of MIMO, and that might have seen many times earlier. So we come to the cognitive radio. This is basically the start of the reason behind using artificial intelligence in the 5G network. Of course, the lecture stress will be aspects related to artificial intelligence in 5G technology. So cognitive radio is what? Cognitive radio is an adaptive smart radio and network technology that can automatically detect the available channel in a wireless spectrum and change the transmission parameter, making more communication to run at the same time. This statement itself tells that 5G technology is very much different from the existing 3G or 4G technology from the philosophical aspect, because in 3G and 4G technology you don't have such a facility that you can dynamically change the transmission parameters so that the spectral efficiency is improved. The things are very much fixed, and fixed set of rules are being defined initially by the service provider, and the user has to confine with these rules. And of course, if we put the constraint of confinement constraint, then certainly the spectral efficiency, better spectral efficiency is rarely achieved. So this is the cognitive radio cycle, which is basically the in a cycle we have radio environment, spectrum sensing, spectrum analysis, and spectrum decision. So it is a continuous process. Radio environment is there, spectrum is sensed, a spectrum, either a spectrum decision is taken, or the things are put up in the spectrum analysis where it is being observed whether we have the availability of already transmitted band, some availability is there, can it be accommodated in that particular channel, then accordingly channel capacity is being allocated to particular channel, particular requirement, and then spectrum decision is taken place, then the transmission takes place. So this is a very much important diagram from the aspect of using AI. This is the where we have we are able to get the flexibility in 5G technology, that numerous number of devices can be accommodated, and those with their intensive applications with the unique IP addresses. So 5G, how 5G technology is achieved? New multiplexing technology is there, in which efficient spectrum utilization has to be achieved. Better energy saving schemes are possible. New spectrum allotment can be done, and the application specific improvement can be achieved. How application specific improvement can be achieved? By this cognitive radio cycle. So this is still a topic of research, that how by using this cognitive radio cycle or modifying this cognitive radio cycle can we achieve these objectives associated with the 5G communication. So this is what is the crux behind the development of 5G technology. So we can give a quick review on the problem of OFDM. So need guard bands. Entire band should be of the same subcarrier spacing. Entire time should use the same symbol size and cyclic prefix. All users should strictly time synchronize in the uplink. What does this mean? That set of rules are fixed as far as OFDM technology is concerned, and this OFDM is very much useful, but not in this scenario that we are showing over here, because as far as 5G technology is concerned, we need the development in this particular technology, and by that way the spectrum efficiency can be improved, and that way it will be more useful in context to 5G technology. So modification with the multiple access technology multiplexing is the spectral filtered OFDM, filtered bank multi-carrier, non-orthogonal multiple access, pattern division multiple access, low density spreading, sparse code division multiple access, and interleave division multiple access. So these are different technologies. The motive behind them is that as per the given scenario, we should use a certain technology so that we can improve the spectrum utilization as per the requirement of the a particular scenario. So we will skip it because our main purpose will be on related with AI. So I am just showing you these slides, that how these different OFDM versions work. So band is subdivided into multiple subbands. So spectrum filtered OFDM is there. Subbands are of different sizes, and this way different users do not need to be time synchronized. So this is the asynchronous OFDM, and each subband spectrum is filtered to avoid the inter-subband interference. So this is the way how the spectrum allocation is being done in the spectrum filtered OFDM. Means the spectrum subbands are of different bandwidths, their spacing are different as per the needs, and these use for each subband may differ using different OFDM parameters optimized for different applications. Similarly, we see filtered bank multi-carrier. We have multi-carrier, and we see that node side lobes are there. Different users can have different subbands with different parameters. Non-orthogonal multiple access, which is NONA, in which users are distinguished by power level. Users with poor channel condition get higher power. This is the adaptation. Poor channel will get the better power because that depends on the distance from the cell transmitter. And users with the higher power decode their signal, treating others as noise, and it can also be used with beam forming and MIMO applications. This is a pattern division multiplexing. This is the variation of NOMA, in which different type of signals could be generated depending upon the different type of requirements. So with this way, we can increase the spectral efficiency by a factor of 1 or 2. So I will skip now. Low density spectral spreading is one more technique. Sparse code multiple access is another technique. Interleave division multiple access is one more technique. See the way the packets are being generated, how the multiplexing is modified to attain the better spectral efficiency to accommodate as many users as we can, and how the interleaving of the pattern is done. Interleaving means we have a data symbol, we have an interleaver by which various number of users are clubbed together in a certain multiple access technique. Here in interleave division multiple access, basically CDMA is the core multiplexing technique which is being used. So new efficient spectrum usage techniques belongs to 3D beamforming, that is MIMO, FDD, TDD, and the others that have been mentioned over here is distributed antenna system, simultaneous transmission and reception, dynamic TDD, license assisted access, multimode base stations, intelligent multimode, random access terminal selection, higher order modulations, and in small cells. So this is the 3D beam forming, a massive MIMO systems. A certain system is generating different beams having a different power levels, and by that way different connectivities are possible with different devices. So FDD and TDD carrier integration. So these type of different packets are used by using frequency division multiplexing or time division multiplexing together. This is dynamic TDD. The dynamic TDD is time division multiplexing, allows varying uplink to downlink ratio. All cells in an area must synchronize their UL and DL subframes. So this way we see that these are the different type of techniques that are being used in 5G technology. So now we see that this shows the evolution up to 5G. We see that we have entered in an era where we will uh, see the evolution of 5G in our networks, and how this will be done is associated with the use of AI and machine learning approaches. So we see here three key frequency ranges that are currently worth of consideration for different 5G deployment is, as we have seen earlier, this is sub 1 gigahertz, 1 to 6 gigahertz, and above 6 gigahertz. So they have different utilities. This is ideal coverage band, could provide a very useful means of extending a superior 5G user experience into rural areas and deep inside the buildings, because these have large line of sight distances are possible. In the 1 to 6 gigahertz, we are in a position to deploy numerous existing mobile bands. Although these bands offer a reasonable mixture of coverage and capacity, because as we have increased the frequency, coverage will be a bit lesser, but still it is useful because not more number of antennas are required in this particular band. And if we talk about 6 gigahertz, this spectrum could support very wide channel sizes, and because the frequency is high and therefore extremely fast data rate is possible, and massive additional mobile network capacity, making it fertile for 5G research. But the limitation is also there, that heavy reliance on these bands without complementary lower frequency spectrum may mean that 5G services are limited to small urban areas or inside the building, as its radio frequency propagation quality degrades, and this favors the small cell size as well as more number of antennas. So more number of antennas will be required. So this is the band that is associated with the 5G. So this is the new spectrum that we will skip. So above 6 gigahertz is what? Free space loss increases in the proportion to square of frequencies. This is associated with the properties of wireless communication, and square of distance. It comes from the basic formula of free space losses, free space communication. By that way, we design the link in a free space communication, and this is very high in the case of higher frequencies. Outdoor to indoor is the additional loss of 20 to 40 dBs. Mobility, Doppler shift is proportional to frequency and velocity. Multipath results in varying Doppler shifts, lower mobility. So this is again a constraint. Wide channels, duplex filter covers only 3 to 4% of center frequency, need carrier aggregation. So this is the aspect associated with beyond 6 gigahertz of communication. But we see that 2 Gbps to 1 kilometer is a feasible using millimeter waves. This is one of the most uh, benef- benefit associated with the high frequencies transmission of the 5G communication. So this is the review that we have seen. So existing 4G is basically LTE or WiMAX technology. In comparison to 5G, we use high frequencies, and that is a shift of paradigm from single discipline to multidiscipline, because not only we are uh, able to provide the need of communication associated with voice and data, but we have the motive to super high capacity of or ultra high capacity of speed of data communication with the new design requirement associated with the 5G technology. That way, we are in a position to integrate many of the devices by using the 5G technology. So we see again the key associated with 5G: energy saving, dynamic antenna, software defined networking, network function virtualization, mobile edge computing, cloud random area access network, high throughput, improved spectral efficiency, reduced latency, better mobility support, and high connection density. So these are key associated with the 5G technology. And of course, we should stress upon here one important aspect is that due to all these functionalities, it is possible for us to include the features associated with ML and AI, because that requires high computational requirements. If the latency is very low, then only we are in a position to use the artificial intelligence and machine learning in the communication technology, and this is only possible with the 5G technology. So again, we see cloud native 5G architecture is key to enabling diversified service requirements by using random access networks. This is very, very important associated with the 5G technology. Cloud native 5G architecture support is there, and that is possible due to high data rate as well as low latency. And third one is high computational speed of the device that we use for the purpose of communication. So device to device communication is possible. This is new. It is something like that by Bluetooth, one mobile is connected to the another mobile, but that is quite a short distance with quite a good limitation of the data rate. So if within the cell you are in a position to communicate one device with the other device by directly identifying its IP address, then the control of the network through cloud computing, cloud server will be very, very much efficient. And that is why the and machine to machine communication by allotting unique IP address. So with software defined networking and network function virtualization supporting the underlying physical infrastructure, 5G comprehensively cloudify the access, transport, and core network. So this is the SDN. This is the abstract hardware, programmable, centralized control of policies there. So this way, the control user can control the network through access of 5G technology. So network function virtualization. This is associated with the standard hardware is fast and cheap. No specialized hardware is required except its computational capability. Implement all functions in software. And another very, very important is virtualize all functions through cloud and create the capacity on demand. As per the requirement of demand, we are in a position to take the decision and implement it in quite a lesser time. That is why again and again we are putting on the stress on latency requirements. So mobile edge computing, again the same thing, that to service mobile users or IoT, the computation needs to come to edge. So mobile is in a position to do the computing through cloud servers, and by that way the different devices can be controlled. This again, this is cloud random radio access network. This is the centralized baseband processing in a cloud. Need to carry high bit rate signal from tower to cloud side, and this should be in the range of 10 Gbps. And of course, this requirement will be able to complete by use of Ethernet network. Of course, high speed Ethernet network will be required, or optical fiber, and microwave as well. So that depends upon the type of distance. Of course, the range, if we are going to the higher frequencies of transmission, the range will be reduced as far as transmission is concerned. So we see that the two situations are there: distributed radio access network or cloud random access network. So both of the possibilities are there, but in cloud random access network, we are the whole the computation is being done by the cloud. And in the case of distributed area network, you are able to do this thing on the distributed systems, and that way the cloud is not that much loaded. Again, these are the typical parameters associated with the 5G technology. We have seen various multiplexing standards, spectrum utilization, efficient spectrum utilization, energy saving, and application specific improvement, and the parameters that is associated with mobility support, latency support, density of connections per square meters, spectral efficiency, traffic capacity. These are the important parameters associated with the 5G communication. Now we come to the topic, that is artificial intelligence in 5G technology. Basically, in the slides that we have seen just now, we tried to revise basic fundamentals associated with 5G technology, together with the notion that how 5G is able to use artificial intelligence, machine learning, and so that our uh, computational requirement can be achieved by using 5G technology. So we see it, artificial intelligence and its subcategories like machine learning and deep learning mechanisms allow fifth generation wireless networks to be predictive and proactive. This is the first requirement. Then only this can only be the reason for efficient spectrum utilization, which is essential in making the 5G vision conceivable. Because unless we have better spectrum utilization is not available, it is not possible to interact among many devices simultaneously as per their requirements, as per the current scenario. Similarly, in 5G, mobile devices creating dynamically adaptable clusters based on learned data rather than pre-established and fixed rules, that will improve in the efficiency, latency, and reliability of the current and real-time network applications in general. See, the second one is basically creating a difference between 5G and its earlier versions, that is 3G and 4G. There is, in the 3G and 4G, there were pre-established fixed rules were there. There was no scope of increasing the efficiency. The reliability was very much dependent on the network only. And of course, as far as real-time applications is concerned, that is achievable but not guaranteed. So these all things are being incorporated in the 5G services. The third one is network related issues can be tackled by adopting the capability of learn offered by AI along with the dense amount of transmitted data or wireless configuration data sets. So we now forward. Madam, is it audible? Hello, is it okay as far as audibility is concerned?
Audible, sir.
Okay. So artificial intelligence in 5G technology is the next generation of mobile and wireless communication technologies. Also requires the use of optimization. This is again one thing that puts burden on the network. As far as machine learning and artificial intelligence is concerned, that means our device is taking certain decision based on certain set of rules that we may call as an algorithm or optimization techniques based on best suited results. So we have the next generation technology that may use the optimization techniques to minimize or maximize certain objective decisions functions. These objective functions gives most optimal solutions, and that will be implemented in the current scenario in the 5G technology. Similarly, problems in mobile and wireless communications are not linear or polynomial. In consequence, they demand to be approximated as per the current scenario. Okay, and artificial neural network is an AI technique which is suggested to model the objective function of nonlinear problem that requires optimization. The problem is linear, we do not need any optimization technique. We can frame a certain rule, and accordingly the decision will be obtained, and that will decision will be final one, and we that will also going to work in a perfect manner. But if the problem is a non-linear problem, we will see in next few slides, if the problem is a non-linear problem, then certainly the fixed set of rule is not going to work. Then we have to modify the algorithm by training them or by use of optimization techniques so that best decision can be obtained. The potential of AI from ML, deep learning, etc., helps to fulfill the diversified requirement of 5G standard to operate in a fully automated fashion, so that the increased capacity demand can be achieved with better quality of service. So this is a diagram that shows the relationship between the artificial intelligence, machine learning, and deep learning. As the diagram suggests, that artificial intelligence means any technique that enables the computers to imitate human behavior. That is the artificial intelligence. A big set. Machine learning is a subset of artificial intelligence which is associated with algorithms which use the statistical techniques to allow the machine to improve their experience. Experience means past behavior, to improve the past results, to improve upon the experiences of the past, and that is why it is known as machine learning. Learning from the past experiences and to improve the decision in such a manner that better optimality can be achieved. And another subset of machine learning is the deep learning. That is, of course, a very precise decision. That is subcategory of machine learning, which involves the multi-layer neural network computation. And basically, the machine learning, deep learning, and a part of AI are useful in case of 5G technology. Of course, AI is the big set, and that requires a lots of research even today, so that how we can improve the human behavior so that machine can imitate the human being. And machine learning is basically improving the decision of a machine. We have said we have a certain set of static rule which works fine, nicely in a certain static scenario. But if the scenario is not static, scenario is dynamic, then certainly the set of rules is to be modified to get the best optimal result. So where this is what where we feel the requirement of machine learning. So we see the traditional programming is the first one. Traditional programming is what? We have certain set of rules, we have certain set of data, we pass it through the traditional programming technique, and where certain decisions are bounded decisions are there, and we get the answers. So this is the traditional programming technique. Means fixed set of rules are there, and accordingly we are going to achieve fixed set of answers. There is no dynamism involved in this particular type of programming approach. Okay. The second one is supervised learning. Supervised learning means we have the known answer is there, we have the data is there. So based on this, we decide the set of rules. And once we get a good rule, this is known as tuning of rules. Once the rules are framed, then based on those rules, if data is given as an input, we get the output, that is answers. पहले तो हम जो ट्रेंड थिंग्स है उनके लिए आंसर देखते हैं, तो आंसर इनपुट में है, डेटा इनपुट में है, तो वी सी that rules should be framed in such a manner that it is very much near to the known answers. Once the rules is fixed, this is done by supervised learning training phase. Then we take a new set of data, and based on the trained rules, we get the answer, and this is known as supervised learning. पहले एक सेट नोन सेट से हम जो है रूल्स को फाइनलाइज करते हैं, that requires a training phase of supervised learning, and thereafter we put any unknown data. ट्रेनिंग सेट ऑफ डेटा के अलावा जो डेटा है उसको किसी को भी डेटा को हम इनपुट में देंगे. अब हम ये मान के चलते हैं कि हमारी जो लर्निंग है, हमारी जो ट्रेनिंग है, हमारी जो ट्यूनिंग है, दैट हैव बीन नियर टू द परफेक्ट. तो अब उसके बेसिस पर हमको जो रिजल्ट मिलेगा वो एक्सेप्टेबल रिजल्ट मिलेगा, ठीक ठाक रिजल्ट मिलेगा. इस टाइप की लर्निंग को हम कहते हैं सुपरवाइज्ड लर्निंग. अनदर सेट ऑफ लर्निंग टाइप ऑफ लर्निंग इज अनसुपरवाइज्ड लर्निंग, where input is given and we see that rules are defined directly without giving any training. And the last one is in the reinforcement learning. Reinforcement agents are there, action is there. So we have reward or penalty type of thing. In the feedback, lower arrow, that is reward oblique feedback. So of course the target will be to increase the reward, reduce the penalty. So in that way the reinforcement learning is there. So this agent is in a position to train the set of rules, and finally those could be used. And I think as far as I have seen your today's timetable, your lecture after the lunch by professor at IIT Ropar is based on reinforcement learning. So we come to the supervision levels in AI training stage. First is the supervised learning. In supervised learning, each training example has to fed along with their respective label. The notion is that training a learning model by a large set of data. This is very, very important, that during training your data set should be a large one. Otherwise your training, or you can say tuning of your data, by which you are expecting a reasonably acceptable result, will not be a successful result. So the notion is that training a learning model by using a large set of data on a sample of the problem instances with known optima, and then use the model to recognize optimal solutions to new instances. Supervised learning also involves regression and prediction, where the task is to predict a target numerical value given a set of features, attributes, that is called as predictors. So we will see it in the next diagram, that it is associated with supervised learning. Say our output is something like this. So underfitting is there. So it is something like this. So no data is near to the actual captured values. So it is a linear. Why? Because we are using a linear function, and linear function is unable to capture the curvature of data. Means behavior, behavioral pattern is not captured by if you use a linear function. So instead of this, if we use a quadratic function, then this data fits to a good extent, and we see the generalization is good enough as far as the fitting of the data is concerned. In the third scenario, we see a polynomial of higher degree. Quadratic function is से भी higher degree का polynomial अगर हम use करते हैं, so that fits the data very accurately. But the problem with the third one is that it fails to generalize the unseen points from the underlying situation. मान लो आपको एक नए एक्सपेरिमेंट में कोई भी डेटा थोड़ा सा भी दाएं बाएं होगा, then it will fail because this is the scenario of overfitting that will require higher order polynomial curve fitting. That, of course, the accuracy during training phase is very good, but that accuracy may fail the unseen points from the underlying function. And one more typical thing associated with this is that this particular overfitting is requiring more computational time. See, this is a good curve fitting, but one point has been left over. And for this, this overfitting gave another relationship. So the same output have been defined by two relations. One relation is this one, another one relation is this one. So it is the best suited answer because all of the points associated with our results have been fitted in the quadratic function properly, and it is well adaptive so that it can uh, uh, it has the ability to fit the new unseen points in the new set of data. So out of the three, this is underfitting, this is a linear function, this is not going to work. So this is the quadratic function. This is another higher order polynomial, and due to this we see the slope is very high. That is why this point has been left alone. So for this function I have been defined this single point as a single entity, and another function have been declared for this, which is certainly not a true correct situation. So we see the next stage of learning, that is unsupervised learning. The training data is unlabeled and the system attempts to learn without any guidance. This technique is particularly useful when we want to detect a group of similar characteristics. At no point we tell the algorithm to try to detect groups of related attributes. The algorithm solves this connection without intervention. So this is a typical thing associated with the unsupervised learning. No training phase is being used. The data itself is being detected in such a manner that it is able to solve the algorithm. So we see unsupervised learning over here. This is the set of data, the initial set of unlabeled data with the different user equipment distributed along a two-dimensional feature axis. And unsupervised learning algorithm puts them in clusters, and the instances after being fed into the unsupervised learning algorithm, we see that the clustering arrangement does not require any supervision. They have been divided in three clusters. They have been classified in three subclasses by unsupervised learning examples, and this is without any learning algorithm. So this is known as clustering. In the scenario of clustering, this can be done quite nicely. The unsupervised learning can be used. The third one is the reinforcement learning. It is based on learning system often called as agent that reacts to the environment. The agent performs actions and gets rewards or penalties. Penalties, of course, a negative reward. in return for its actions. That means the agent has to learn by itself, creating a policy that defines the action that the agent should choose in a certain situation. The aim of the reinforcement learning task is to maximize the reward over a period of time. So we see it by this particular diagram. We see that there are different ways of reinforcement learning. Uh, More details you will see, I think, in the afternoon session of today. So Markov decision process. So action reward is there. We continuously monitor the situation and accordingly we generate a set of rules, and this is partially observed Markov decision process, and the third one is Q learning. So there are three different approaches by which the reinforcement learning is being uh, done, and by that way we try to minimize the penalties and we try to reach to it is something like optimization. We can say in optimization, when we maximize or we minimize, say we try to minimize a certain function, then we run the algorithm for certain number of times, and out of those certain number of time, whatever is the minimal possible value is there, that is termed as a decision of that optimization algorithm, and accordingly the situation is being handled. So we see now come to the point that how these techniques are used in our 5G communication technology. So we will take certain examples, and of course these examples will help us what we have seen earlier in case of in during our study of 5G networks, that how the learning models are going to be used in certain 5G applications. So Balavi et al incorporated fog networking into heterogeneous cellular networks and used the unsupervised soft clustering algorithm for what? To locate the fog nodes that are upgraded from low power nodes to high power nodes. And this is going to reduce the network latency. If nodes are changed from low power nodes to high power nodes, then of course this is being trained by unsupervised soft clustering algorithm, and by that way nodes are upgraded, and accordingly the cell devices, different devices connected with that cell will be informed uh, that the node have been upgraded from the low power nodes to high power nodes. And of course, the purpose of this is to reduce the network latency. Why we feel the requirement of this? Because say in a certain small cell, suddenly the demand of traffic increases. So initially declared low power node has to now handle high traffic, which it is unable to do. So now by using clustering algorithm, the system is able to understand by its past data behavior that the traffic is suddenly increasing. Based on that particular traffic, those nodes are converted into a high power nodes, and accordingly the latency is reduced. A typical unsupervised learning technique is k-means clustering algorithm. This is also a k-means a popular algorithm which is used for cooperative spectrum sensing algorithm using a combination of optimized version of k-means clustering. Means spectrum sensing is being an algorithm by which we try to sense the vacant spectrum in a certain 5G communication transmission, and accordingly this free spectrum is being allocated dynamically to a new user without any uh, without more latency. Similarly, we see that reinforcement learning has also played an important role on heterogeneous networks, enabling femtocells, to autonomously and opportunistically sense the radio network environment and tune their parameters accordingly to satisfy the specific preset quality of service requirement. It is again a very important function. It means the system is continuously monitoring the quality of service. as we are very much familiar that traffic demand is a dynamic situation, and if demand increases, certainly it puts a great burden on quality of service. So accordingly the system parameters has to be enhanced in such a manner so that the quality of service parameter requirements could be matched accordingly. So reinforcement learning plays a vital role in it. See one thing, again and again I stress upon one thing, that the requirement of users is going to increase by manifold in 5G communication networks. Many things we are in a position to control by our own direct communication with the devices, and of course this requires a high speed network with low latency requirement. So because of that only, due to if these things are available, then only we can use AI, machine learning or deep learning type of things in 5G applications. Because see, any algorithm that we run for machine learning related, AI related or deep learning related, that will take its own certain time to decide. Then only the further task would be completed. So if the network is in a position to do it in a good manner, then only it will be able to reallocate the resources so that quality of service is maintained up to the desired standard. So use of AI in 5G is associated with LTE. Small cells are increasingly being deployed in 5G networks to cope with high traffic demands. These small scale cells are characterized by its unpredictable and dynamic interference patterns, expanding the demand for self-optimized solutions that can lead to lower drops. See, these are the traffic parameters that can lead to lower drops, higher data rates, and lower cost for the operators. Self-organizing networks are expected to learn and dynamically adapt to different environments. This is very, very important, that self-organizing networks, which is the utmost requirement of 5G network, is that self-organizing network are expected to learn from the existing scenario and dynamically adapt to the environment in such a manner that quality of service is not at all hampered. The next one is machine learning and statistical regression techniques are evaluated by gathering radio performance matrices such as path loss, throughput for particular frequencies, and bandwidth settings from the cells, and adjusting the parameters using learning based approaches to predict the performance that a user will experience given previous performance measurement samples. So this is what we are trying to stress upon again and again, that based on the available radio performance matrices such as path loss, throughput, data rate, the cell parameters are adjusted to predict the performance that a user is going to experience based on the current demand of that particular cell. Similarly, learning-based dynamic frequency and bandwidth allocation prediction methods yield outstanding performance gains, with bagging tree prediction as most promising approach to increase the capacity of next generation cellular network. This is very, very important, again a statement associated with 5G, that our model of 5G communication is quite different from the static model of 3G and 4G. Here, we see that it is going to be a learning-based dynamic frequency and bandwidth allocation that will be based on the current scenario. So prediction will be done beforehand so that least latency is observed, and accordingly the uh, utility or resources are being redistributed as per the user demands. So again, next one is the application of their work can be extended to cell selection in multi-tier networks, device discovery from device to device communication, or end-to-end user association for load balancing, among others. The machine learning framework receives the traffic-aware knowledge from the software-defined network controllers and adjusts the uplink and downlink configuration in the LTE radio communication. Of course, the subcell can work by the existing technology, but the overall control of the network will be in such a manner that 5G is in a position to use the various ML AI techniques together with cloud computing. Artificial neural network have been proposed to solve the propagation loss estimation in dynamic environments where the input parameters can be selected from the information of the transmitter, receiver, buildings and frequencies, so on. And the learning network will train on that data to learn to estimate the function that best approximates the propagation loss for next generation wireless networks. See, here again the statement is associated with use of ANN to improve the quality of service, to improve the new demands of service, so that the estimation of the function is done in such a manner that the propagation loss is minimized, and uh, the situation is that our network in totality is able to handle the dynamic situation. Here we see that these are few of the, this is very interesting table, and I will show that from where I have taken it at the end, and this is also very much be useful for the researchers to work in the area of 5G and AI related fields. So we see the first one is the supervised learning. So these are the different models that works on the supervised learning model, and we see the application of mobile and wireless communication. So we see that predict and model energy availability to define scheduling policies of harvesting nodes, providing the harvesting node with adaptation of energy availability. So these are the few of the references from that magazine that I have taken. So these are the papers that have been used these particular techniques, that is line regression based supervised learning, have been used in this particular application of mobile and wireless communication. Similarly, statistical logistic regression technique of supervised learning have been used to allocate dynamic frequency and bandwidth in self-organized LTE dense small cell deployment. Similarly, supervised classifier-based learning approach have been used to predict the network demand, to dynamically allocate the amount of network resources, topology, setup and bit rate according to the connectivity performance, that is bandwidth, latency and jitter. Jitter is the noise. Similarly, support vector machine based supervised learning have been used in 5G related application for path loss prediction model for urban environment. The classification of the training channel state information is used to optimally select the specific antenna for MIMO applications. This is again an application. Similarly, we can see there are different applications. Those are based on supervised learning models, different types of supervised learning models. Similarly, unsupervised learning model, we can see over here, these are different type of unsupervised learning models, and these are different type of application. The first one is cooperative spectrum sensing. Second one is anomaly fault intrusion detection in mobile wireless networks. This one is the unsupervised soft clustering, is for reducing the latency, for by clustering a fog nodes to automatically decide which low power node is to be upgraded to high power nodes in a heterogeneous cellular network that we have just discussed earlier, to enhance the requirement of a specific cell as per the need to handle the high traffic demand generated recently. Similarly, others. So we can see that there are lots of research papers. Those are using different technologies to, of course, the motive is simple. We have the motive to either improving the services in the 5G network or including a new services that could be used that can use high data traffic and lower latency features of 5G for certain computing related applications. Similarly, reinforcement learning, there are 5 6 different type of reinforcement learning, and those are used again for different scenarios of 5G communication. So we see here one diagram, a symbolic diagram, how the AI or machine learning works in the scenario of 5G communication. And this is the process of automatic adaptation of machine learning algorithm. Training data is used for machine learning model to learn the pattern or features. After the ML algorithm deployment, the errors may be used to correct the model automatically in an iterative fashion. We see that this is a cell and device, and the raw data collection is being done over here, by which the monitoring of resources is continuously done. Quality of service parameters are continuously monitored. So data labeling is being done. So this is training data, this is the testing data. So model training is being done, and based on this, we see that error is being calculated, and accordingly the model is being implemented based on this reducing this error function. Continuously this model is being trained by using test data. This is standard test data. This is the training data. Data can be split in two parts, training phase and testing phase. So initially we can say the training phase, and later on it will switch to the testing phase. Testing means real scenario. Training means initially you create the scenario deliberately, manually, and try to see whether our system is in a position to handle this scenario or not. If it is not in a position to handle the scenario, we train this model in such a manner that it is being minimized, this error is being minimized. Once we ensure that our training phase is working nicely as far as this error is concerned, then we switch to the testing phase. This is the real time scenario where, based on this training model, we use this data, and accordingly we use this hypothesis from received from here, and we try to calculate that in such a manner that the error is being minimized. So this is known as ML training. And of course, by this way, of course, where it is going to play its role in our 5G communication, it is going to play its role in 5G communication in various decisions related with spectrum allotment, related with enhancing the data rate or reducing the data rate as per the requirement, or accommodating numerous number of devices within a limited cell region. So we see that our learning methodology can be subdivided in two broad categories. We see we have uh, heard many times the word associated with artificial intelligence, associated with machine learning, associated with deep learning. So this particular picture is very, very important from the context of uh, uh, two broad categories, that is accuracy versus interpretability. So these are the two approaches by which we can subclassify all these different models. So we see if the things are very much accurate, then the neural network SVM, random forest techniques works in this particular range where the accuracy is more. So high accuracy models, what are the typical features associated with high accuracy models? They are non-linear relationship. See, because their relationship is non-linear, that is why their accuracy is more. हम जो है सुपरवाइज लर्निंग में ट्रेनिंग फेज में देख चुके हैं एक लीनियर रिलेशन, एक क्वाड्रेटिक रिलेशन और एक हायर ऑर्डर पॉलिनोमियल रिलेशन. जैसे जैसे ऑर्डर बढ़ेगा नॉन लीनियरिटी रिलेशनशिप होगी किसी पर्टिकुलर मॉडल में, द एक्यूरेसी विल बी बेटर. It is a non-smooth relationship, and because of that only the curve fitting, better curve fitting is obtained. But the typical thing associated with high accurate models are that they have a long computational time. So some computational time will be required, computation time will be more. So this comes the reason associated with higher accuracy model. And the another one is low accuracy model, but they're interpretable models, highly interpretable models means they are in a position to judge the things quite easily. They are following either a linear relationship or a smooth relationship, and is quite easily computable. So that is why they are termed as highly interpretable models. Decision trees, linear regression models, k nearest neighbors, or set of rules, classified rules, comes under this category where interpretability is more, but the accuracy is low. But of course, here the engineering compromise is called for. We have to choose what we want. If we want better accuracy, we have to go for these type of models. But the thing is that because of long computational time, the latency may increase. हमारा जो डिसीजन है जो फाइनली इम्प्लीमेंट होगा उसमें थोड़ा सा समय लग सकता है. और अगर हम इस सिनेरियो से बचना चाहते हैं लेकिन हम एक्यूरेसी में थोड़ा कंप्रोमाइज कर सकते हैं, then these models will be required. Their interpretability is very good because they are requiring quite a lesser time to compute because of linear or smooth relationships, and mathematically they are simple rules, and but accuracy is of course less. So it is up to us to decide in what direction we want as far as decision making is concerned, as far as latency is involved, okay, as far as the type of services we are handling to take the decision associated with a certain type of service. So we see finally we concluded in a few more slides. The AI solutions to 5G network is allowing the baseband to predict kind of content users nearby in near future to allocate dynamic frequencies in dense self-organized LTE cells. This is very, very important. That is by using AI solutions in 5G network, this allows the baseband to predict kind of content users nearby in near future to allocate dynamic frequencies in dense self-organized LTE cells. Next one is predicting the path loss or link budget. Link budget is transmitter to receiver जो पावर कैलकुलेशन होती है उसको हम लिंक बजट कहते हैं. ट्रांसमीटर कितनी दूरी पर है रिसीवर से, कितनी पावर ट्रांसमीटर से ट्रांसमिट हो रही है और उसकी फ्रैक्शन ऑफ कितनी पावर रिसीवर तक पहुंचेगी. Of course, the size of antenna also matters and type of antenna also matters in the design of link budget. So that we popularly do during our satellite communication subject study. So I will repeat it again. Predicting the path loss and link budget with approximated neural network models by inferring the unobservable channel state information from an observable channel by adjusting the TDD uplink downlink configuration. So this is the allocation of bandwidth by judging the path loss and link budget calculation. So few more are sensing the spectrum using unsupervised models. reducing the latency by automatically configuring the clusters. The next one is detecting anomalies called intrusions in mobile wireless networks, managing the resources in ultra dense small cells. The next one is selecting the relay nodes in vehicular networks. This is very, very important. Vehicular networks means the device is in motion at some good speed. So in that case, the latency related issues plays a vital role also. So selecting the relay nodes in vehicular networks, enabling autonomous and opportunistic sensing of radio environment in femtocells, selecting the optimal radio access technology. So finally, we conclude over here that a reliable 5G system requires extremely low latency, and due to this, not everything can be stored in remote cloud servers far away. Latency increases with distance and congestion of the network links. Base stations have limited storage size, so they have to learn to predict user needs by applying a variety of artificial intelligence tools. With these tools, every base station will be able to store a reduced but adequate set of files or the contents. 5G wireless networks contain multiple radio access technologies. However, selecting the right radio access technology is a latent problem in terms of speed, exploration of times, and convergence. An AI-based model plays a vital role in this. So finally, I will show you the, uh, sorry, I have changed the slide. Key references. These are the few of the key references. And one more thing I would like to tell over here is, 1 minute. One more thing I would like to tell over here, if you are interested in doing some research work or more details associated with 5G technology, 5G communication, then Professor Jagannatham in Electrical Engineering Department at IIT Kanpur is having lots of lectures and he do lots of workshops as well as NPTEL lectures also there on 5G technology by Professor Jagannatham of Electrical Engineering Department at IIT Roorkee. Thank you very much from my part and giving me this opportunity to present this work. Thank you, Dr. Garima. Thank you, Dr. Payal.
Thank you so much, sir, for the knowledge what you have shared with us. I suppose that is very useful for me as I listen your lecture and for participants also. Thank you so much, sir.
Okay.
Dear participants, kindly fill your today's session attendance in the given link in the chat box and please turn on your cameras for a group photograph. Sir, there is a query in the chat box.
Okay, okay.
Can, how can we distinguish regression and classification in ad hoc networks?
I could please, I could not. Okay. Explain how can we distinguish regression and classification in ad hoc networks. See, regression is basically a tool by which we train the model. Okay. We take a certain model and accordingly, this is basically a mathematical technique by which we are in a position to train the network features and take the decision accordingly. Okay. And ad hoc network is basically a model which is being generated for the temporary requirement in a certain scenario.
Okay, thank you very much, sir.
Okay.
Any more queries from the participant sides? I think there are no more queries.
Thank you, madam. Should I leave?
Sir, just a minute. We
I'm
also
audible.
take a group photograph. And thank you very much all. Thank you.
Thank you. Thank you very
Thank
much.
you, sir. Thank you, sir.
We will again meet at 11:45 sharp for the second session.